Hello everyone, we are working on 5.6 and 5.7, the sine and cosine laws. So you did sine and cosine law in grade 10, so it's important that you review for yourself, if you haven't yet, what the sine and cosine laws are. If you look in your textbook under Appendix A in the back of the book, that's on page 573, you will see a review of these laws. So it goes over the sine law and it goes over the cosine law. There are examples that you can read. There's 2 examples if you flip the page, and then there are some practice questions. So if you need to review the sine law and the cosine law, that's where you go, page 573. Also, page 274 in your textbook has some more practice questions for the sine law and the cosine law. So there's lots of places for you to practice. Today, we're going to build on what you already learned about the sine and the cosine laws, and we're going to talk about a new feature of them that happen. But let's review first the sine law and the cosine law quickly so you know when to use each one. So take a look at your handout that you've printed off or that you are looking at on your screen right now. The first bullet says to use the sine law, you need to know one ratio of a side and an angle without any unknowns. So if you look at the screen here underneath the sine law, let's say we know angle C and we know side C. They're opposite each other. So if we know both of those values, if they were given to us in the question, then the sine law would be the best one to use to solve the question. The cosine law is best to be used if you know all 3 sides. The measurements of all 3 sides were given to you in the question. So you know the lengths of all 3 sides, then the cosine law would be the best one to use. All 3 sides. Also, if you are given the lengths of 2 of the sides and the angle between them. So angle A is contained between side C and side B. So think of side C and side B as edges that are holding together that corner, angle A. So angle A is contained by or held in place by side C and side B. So if you know the length of side C and you know the length of side B, and you know the measure of angle A, then the cosine law is going to be the best one to use to solve that triangle. Okay, so the cosine law is best for 3 sides or 2 sides in the contained angle. The ambiguous cases are a new one now. So the ambiguous case occurs, you wouldn't have had one of these in grade 10, an ambiguous case question. This is when we don't have the contained angle in between the sides that we're given. So if we look at this triangle here, this one has a contained angle, right? The 42 degrees is being contained by the 19 centimeter length side and the 17 centimeter length side. So that would be the cosine law because it's the contained angle. 42 degrees is the angle that is contained by or held by the other sides. So this would be a time when we would use the cosine law. It is not the ambiguous case. So you see these are my 2 sides here, and they're holding in the 42. So contained is an important word. That's why you're hearing me say it a lot and try to explain it a lot. That angle is contained by those 2 sides. If we had this Z angle here, if we were given the angle Z, not X, then it would be ambiguous. A triangle is ambiguous when you're given the length of 2 sides and not the contained angle. So here's our first example. Annie's house is 27 kilometers from Chris's house. Chris's house is 22 kilometers away from Brian's house. Draw a triangle ABC illustrating this situation. We're also given a few more pieces of information here. If you look at your handout, you'll see there's extra parts to this example. I'm not going to do them all because just for the e-learning, the online learning, this is one portion of the ambiguous case that I'm going to take out. It's a little harder to do all the drawing. It's harder for me to teach you that. So we're going to focus with the first part of the question here, part A on your handout. So here's a line, and we've got Annie's house and Chris's house, and 27 kilometers between them. So draw one piece at a time, right? Then we've got the next thing that we have is Brian's house. Brian's house, we don't know how far away it is from Chris's house. We don't know the angle. We don't know where it is. We know it's 22 kilometers away, but we don't know the angle. We don't know where to draw that. So I don't know where to put that line right now. So that line, you could think of that as ambiguous. It could go anywhere. All I know is it's 20 kilometers. But I know that angle A is 40 degrees. So there's my angle A. I'm going to try to measure that as best I can on this app, but you guys can do it better with a protractor. So I'm going to put angle A in here. I'm trying to make angle A to be 40 degrees, but I don't know the length of this side. I don't know how far Annie's house is from Brian's house. So I don't know how long to make this line. So this is where we have a problem. This is why we have an ambiguous case. There's too many unknowns here. I know this has to be 40 degrees, this angle that I'm trying to put in here at A. I don't know the length of this side, the one that you saw me draw before coming out from C. I don't know how long to make that side. I don't know what angle to put that side on. So there's too many unknowns. So this is an ambiguous case. This means we're going to be able to draw more than one possible triangle to answer this question. So what we're going to work on here is we'll start with one triangle as if we were in grade 10, how we would have drawn it. And then I'll show you some other, the other option we need to consider for the ambiguous case. So we're going to finish drawing what we can. We have a little bit more information to put in the triangle. So read the question, fill in the rest of the information, press pause, and then come back. All right, we've got all our information in there. And now let's start solving the question. So you need to think back to grade 10, right? What would you have done in grade 10 if you were here? Hopefully you would think of the sine law or the cosine law. And the sine law is best used when you know an angle and you know its opposite side. And we know that here. So we're going to use the sine law with that pair that we have. All right, the sine law. Sine law can be used, usually you put the unknown in the numerator. So we're going to try and find angle B. That's what the question's asking for. So I'm going to write sine of angle B over side B is going to equal sine of, now we want to make sure to take the one that we know that I kind of highlighted there in the green color. So that's going to be, we're going to take the sine of angle A and we're going to divide that by side A. And you can write this formula either way. You can flip the whole formula around so that the sides are in the numerators, but we want to have the unknown in the numerator and our angle is unknown right now. So sine B is unknown, so that's going to stay B. But side B, we know what that measures. That's 27. We don't put the kilometers in the equation. We just write it like this. Sine A, so angle A, that's the only one we know. That's 40 over side A. And side A, that's the lowercase a, so that's our 22. So now that we have all of this in place, we're going to go with cross multiplication. So I'm going to multiply these two together using my calculator. I'm going to find sine of 40, multiply that by 27. And then I'm going to multiply this up here, but the B is still unknown. So what I'm going to have on my next line is 22 times sine B. There's a way to skip this. You could skip this step here if you wanted to. And then on the calculator, you're going to do 27 times sine 40. And then we're going to have to isolate B, right? So to isolate B, I'm going to divide both sides by 22. Divide this side by 22. These will cancel out. And I'm going to write down what I've got here on my calculator. I've got sine B is about 0.7889. So why don't you pause it here for a second and check my math. Okay, so if that looks good, then you have to do inverse sine. That's how we isolate. In order to isolate B, right, we need to do inverse sine of both sides. I'll put it over here. and we get angle B is equal to about 52 degrees. So if you were in grade 10, you would just stop there and you'd say, there, I solved it. Angle B is 52 degrees. But this is where the ambiguous case. Remember how hard it was to draw this triangle because there were so many unknowns. So if you look at your handout right now, it reminds you of something that we talked about last lesson. So I'm just going to put this up here for a minute. This was from our last video lesson, if you watched that one, when we had sine of 0.8 was sine theta equals 0.8, right? And so this is similar to what's happening here. Let me move this up a little bit, shrink it down. Okay. What we've got is down here, looking at this equation, we were at sine B equals 0.7789, which is actually quite identical almost to 0.8, right? So these are almost the exact same question here. We had sine B, so we had a positive value, 0.7889. And if you remember from last lesson, let me just change this here. I can use a lightsaber as a pointer here. Look at that. So from our last lesson when we had, that's distracting, 0.8, when we had a positive value, so we went up the y-axis to 0.8, and then we ended up getting, you go across until you hit the circumference of the circle. We got one angle here, that's the blue one. But also if you go up 0.8, when your y value is 0.8, you can go to the other side, right? And we got another angle, that's the red one here. So we got two answers. And if you look at the bottom, notice that any equation of the form sine equals a number like b above, we have two solutions. So here comes our ambiguous case. So this is tying that past lesson into this lesson. You find one, use your calculator to find one, and that's what you did here. You found this one. You found b equals 52 degrees. You found that with your calculator. But we're going to subtract the first solution from 180 to find the other one. So we have an ambiguous case here because we had this value for sine, 0.70, positive 0.7889, and because we did not have a contained angle. The angle we were given was not contained. The contained angle would have been right here. That would have been the contained angle, right? We did not have the contained angle. So let me just shrink this out of the way a little bit here. Move that up there. So just taking a look at your handout, I'm going to read what it says kind of in italics there on the right side. It says, remember what we learned last class. When sine is a positive number, then theta can have two answers, an acute and an obtuse. Your calculator won't tell you both, so you have to figure it out for yourself. So this is a point sometimes on a test or a quiz where students will give me the first answer, the one we have here, 52 degrees, no problem. But they will forget that because they had originally a non-contained angle, right? This one is non-contained, that there's actually another answer. So both things have to come into play. You have to have the non-contained angle and you have to have this positive value here. So all we have to do to get our second answer is take 180 degrees, subtract 52, and that's going to give us 128 degrees. That means that the angle here, for angle B, that angle could either be 52 degrees, that's the acute, right, 52, or we could have drawn it differently and got 128 degrees. So the next thing I'm going to show you is what that triangle would look like, that one with that really huge angle of 128 degrees. Okay, so I'm just going to kind of do a quick sketch of it here. If we were doing this in class, I would have everybody measuring to make sure sides are the same. This is my, this AC side here is going to be my 27. My pen won't work. Just hang on a second. Okay, so I've got my 27 kilometers in there. Now the C to B, if you can see how short I drew my line for A, this is how I would draw an obtuse angle. Now I'm not measuring it. If we were in class, I would show you how to measure it properly. But that angle right in there, that angle, angle B, would be 128 degrees. If I was measuring it, that's how you would draw it. So that's how we can draw two triangles to answer the same question with all the given information. So we were given that they're 26 kilometers apart, 27 kilometers apart. So I've done that. C to B, sorry, I haven't put the B there yet, but C to B would be 22. We've got a measurement of 40, and then this angle right here would be our obtuse angle of 128 degrees. So if you're looking at your handout, you would be drawing this in part B on your handout, where we would use our protractors and accurately try to measure everything out and scale it all out so it was proper. Underneath that on your handout it says, what is the measure of side C? You will have two scenarios. So side C is right here, and it's also right here. So this does go back to grade 10. We can calculate side C pretty easily because on this one of all the information that we're given. So looking back at our original triangle, I just shrunk down the B equals 52. So we do know that this side now is 52. Sorry, that's kind of a pencil there, and that's pretty faint. So we know this side, this angle is 52. So we can use that information to get angle C up here, right? If this one is 52 and angle A is 40, then we can calculate angle C. Angle C is just going to be 180. Subtract 52, subtract 40. So this angle C is going to be 88 degrees. Now we're going to go over to the other triangle and do the same thing. Our angle C is going to equal, in this case, remember that we got B to be 128. So angle C is going to equal 180, subtract 40, subtract 128. So on this triangle, angle C is 12 degrees, really small, right? Makes sense when you look at the picture. Part C, I'm just going to go through it anyway. We're still doing part C. It says, what is the measure of angle C? So you'll have two scenarios. So on your handout, we're doing example 1C right now. You'll have two scenarios. So to get side C over here, I can use a sine law again. This time I'm going to put the side lengths in the numerator and put 22 over sine 40, because that's the information that we were given in the question, so we know that's correct. And that's equal to the side we're looking for is side C, and that's over sine of angle C, and angle C, we just got that to be 88. So you put all that in your calculator and you will get the answer of, I'll put it up here maybe, therefore side C is going to be 34.2 kilometers. So that's case one. Case two over here, we'll do the exact same thing again. It's 22, that's this side here is 22 over sine of 40 is equal to, again, lowercase c, but angle C this time, remember, is 12 degrees, so sine of 12. You do your cross multiplication to isolate C, and this time you get angle side C to be 7.1 kilometers. So we have two triangles from one question, and that's because we were not given the contained angle, and we had to use the sine law. And when you use sine and you get a positive, you can go back and review that if you need to. You have two possible scenarios. All right, example 2. We're going to change this one a bit. On your handout, it says draw to scale. We're not going to draw to scale. This is something that I'm going to not worry about for this section. You can, if you want to, you can measure 3 centimeters, measure 4 centimeters, measure 35 degrees and solve the triangle. But we're just going to go ahead with just drawing it normally. All right, the first thing I'm going to put here is angle X. Angle X I know is 35 degrees. Now, when you look at the question, this is a lowercase, which means it's the side opposite angle X. So the side opposite angle X has got to be 3 centimeters. And the side opposite angle Z, it's got to be 4 centimeters. So let's say Z is here. If side Z is here, then lowercase z is here. So this is Z equals 4 centimeters here. And again, we have a problem. I don't know how to draw this line for y. I don't know where to put it. So this side here, I don't know the angle to put it at, and I don't know. I might know the length of it, but I don't know the length of this bottom one. So I don't know, do I draw my triangle here? Is it going to be here like an obtuse angle, or is it going to be way over here? I don't know. So we'll just put it there for now. So side X is 3 centimeters. So that's this one here. This is side, oops, what happened there? That's side X. Side X is 3 centimeters. And this is angle Y up here. So I think that's everything we have. The question says solve the triangle. So you can see the angle we have is not contained. Right? It's not contained between these two. That's one of the criteria for ambiguous case, that is not contained. The other criteria is that you end up using the sine law, and you get something like sine equals some kind of a positive number here. If we get that, then we're going to have the ambiguous case. So let's write down what we've got. We're going to use the sine law because we have this opposite angle. We know this angle and this side, which are opposite each other. So when you have an opposite pair like that, the sine law is the best way to go. Put the unknown in the numerator. So I'm going to be looking for, so the question says solve the triangle. That means I need to know every angle and every side. So I'm going to start off first with sine of angle Z over side Z, which is 4. And that's going to equal sine of it, the one that I do know, which is X, 35, over side X, which is 3. You can pause the video here if you want, but you do all your math, multiply this 4 up with sine 35, divide by 3. Then you'll have to do inverse sine. Once you're done all that, you should get angle Z equals 50 degrees. Since we had the step right before our answer, right before this answer, the step would have had, we're using the sine with a positive value. So that's this problem here. We had a non-contained angle, so that means we're going to have 2 cases. 2 cases, right? One is the acute, and that's how we got the 50 degrees. And the other is the obtuse. Then we get the value for the obtuse, if you remember, by just doing 180 minus 50. So our other angle is going to be 130 degrees. Our other case, if we drew it all out, which I'm not going to ask you to do right now. So this would be angle Z here. In case 2, case 1 is over here. Case 2 is over here. So again, the question said solve the triangle. So we have to get all of the angles and all of the sides. We can get angle Y pretty easily. We can do that one next because angle Y is just going to be 180. That's the sum of the angles in a triangle. We subtract the 35 and we subtract the 50. That'll get us angle Y, and then side, what side do we still need? We still need this side over here, right? So we would continue on. I've already done a question like this, and this is a lot of review of grade 10. So again, the only real new thing we're working on here is recognizing that there's 2 cases. Once you get the 2 cases, you get the acute and you get the obtuse, then you solve the triangle just the way you did in grade 10, and you can review the sine law in your notes, but you're going to just have to do it twice because we have a case where we have we use the sine law and we have an uncontained angle. So solving, just remember that solve means to find all of the sides and all the angles. There shouldn't be any unknowns left. On your handout, near the bottom, it says note with the ambiguous case, if an unknown angle in case 1 happens to be 56 acute, then of course the case 2 is going to be obtuse. Underneath that, how do you know when you're dealing with the ambiguous case? So I've already gone over that with you. You've got two things that have to happen. One is a non-contained angle, and the other is you end up using the sine law and you get sine, and sine gives you those two options there. So that's how you know when you're dealing with the ambiguous case. Underneath that is your homework. I'm going to change your homework, so make sure you look back to the D2L page, because I'm going to take out some that are asking you for specific drawings of triangles. So I'm going to weed this one out a little bit. So that's it for today. I hope it wasn't too painful. I will see you soon.